Hey, hi everyone. Welcome back to my YouTube channel. My name is Sagar Utekar and this is day 8 of our free CK series. Today we are going to discuss very important topic for our CK exam as well as for interviews. And you may get asked these questions in your interviews, if not in the CK exam, how authentication works in Kubernetes. And when we type any command on our terminal, kubectl gate pods, gate nodes, what exactly happens behind the scene. And knowing that is very important as a Kubernetes administrator. Isn't that wonderful? Let's get started with that. So far, we have discussed so many interesting topics, such as setting up our Kubernetes cluster on kubeadm. Then we also set up cluster on Minikube, and in the previous video, we use the kind. You can use any cluster for this demo, but I would highly recommend to do hands-on practice and watch all the previous videos so that you will get the hands-on experience. This experience is not only important for solving questions very quickly and save time during your CK exam, but also while working in the production environments as well. In the production environments, when you get a issue, you don't have any timer, but you need to fix those issues as quickly as possible. So that's the main thing I want to share here. Okay, and let's get started with that. So whenever we type any command from our terminal, kubectl gate nodes, pods, or anything else, it we know that it reaches to Kube API server, and Kube API server will handle the next process. But Kube API server make sure that you are the valid user to access this Kubernetes API server or perform this action. So for that, it performs three stages: authentication, authorization, and admission control. And once all the stages are passed, then only it takes the next set of action. Okay. So authentication is nothing but that you are a valid user for accessing this cluster, and authorization in the authorization steps, it will check that you have the right permission to perform the particular action in the Kubernetes cluster. And then admission controllers will do a next set of actions. And yeah, so that is how the Kube API server is going to handle the request first, and then before doing anything else in your Kubernetes cluster. Okay, before jumping into more details about the authentication, I want to make sure that you understand the type of users we have in the Kubernetes cluster. So there are two different categories. One is a human user and one is a non-human user. For human users or the human accounts, we don't have any resource um, in the Kubernetes cluster. We don't have any command, or we don't have any REST APIs. We can't create human user using kubectl create user Sagar, or kubectl create user DevOps. We can't do that. There is no such resource. But for non-human resources, which are part of your Kubernetes cluster, or the applications which are going to communicate with each other into your Kubernetes cluster, there is one resource provided by the Kubernetes, which is nothing but a service account. For both of these type of users, human users and the service account, we need to provide the limited access, or the level of access which is only needed for those users. We can't give the full access. We can't provide everyone admin or the cluster admin access to everyone. And if we do that, you know what will happen, right? Everyone can do any action in your Kubernetes cluster, and uh, maybe they will delete some of the very important resources, and that will take your application entirely down. We really, really don't want that. Okay. Then how we can control the level of access to different users in our Kubernetes cluster? So that is another topic. But today we want to discuss the authentication part, how the users works in the Kubernetes cluster, how we can provide the access to the different users. Okay. So everything in Kubernetes works using a TLS protocol, which is a transport layer security protocol, which is very important and the integral part for securing communication within a Kubernetes cluster, and particularly whenever there is any component which wants to communicate with your Kubernetes API server. To make it very simple, we will not go into detail how the TLS works. Okay, but to make it simple, I'll quickly show you. Our browser is also using HTTPS and the TLS protocol uh, sec for secure communication between this browser and the GitHub server. So if you click on this URL and this icon, it will show this connection is secure, which means the client browser and GitHub server has the connection secure, and there is a certificate offered here, which contains the information about the component or the entity to which this certificate has been issued, and the entity which issued the certificate validity, and the certificate details, and the public key and everything. So similarly, whenever there is any component in your Kubernetes cluster, for example, kubectl is a client and it wants to communicate with your kube API server. Okay, then it needs to have its own certificate, client certificate, and Kube API server needs to have its own server certificate for secure communication. And similarly, we have seen the whole Kubernetes architecture. All these components talk to each other. And for that matter, when we are saying Kubernetes uses the TLS protocol internally, which means every component has its own client and server certificates based on which one is client and which one is certificate. And there is one more entity called as CA, which signs these certificates, which has, we can say that it is an authority which will uh, sign this certificate that okay, this is a right server and this is a right client, this is not a attacker. Okay, yeah, so this is why we are using TLS, or Kubernetes is using TLS. And whenever we are going to discuss about the user who wants to communicate with your API server using your kubectl command line utility, which means as a user or as a client, I need to have my own certificate to talk to my Kube API server. So I have put some of the details here if you want to go over, or I'll create a separate video on how these things works, the TLS handshake in general, and the client server communication, the Kubernetes. Okay. So just to give you overview, we won't go into much detail, but I really can't skip this topic. This is so much interesting. So what happens is that, as I explained, there are three entities: client, server, and the CA. So server gets its assigned certificate before the actual communication start, and this is the workflow. Client establish the connection is a TCP connection with the server, and the actual SSL TLS handshake starts. Then client sends the hello message with different information with the TLS version, and then cipher suits and the compression types supported. Then server responds back with the same information plus its signed certificate, which then client verifies with the certificate authority, and it asks certificate authority to verify that this is a valid server or not before actual communication start. Okay, and that's why we need these certificates for the client and the servers. Okay, and in the same format, server also needs to verify that the communication happening with the client, it is also the valid client and it is not a attacker. So for that reason, the next set of actions happens. Client exchange the uh, its symmetric key, and then with its certificate as well, which server verifies with the certificate authority. And once that handshake is completed, the actual encrypted communication starts. Okay, this is general idea of how TLS works. You can check all these details I have put into my GitHub README. very, very nice topic. Okay. But let's talk about our client-server communication in the Kubernetes. By default, as we discussed, the communication is secured in Kubernetes using a TLS protocol, which is Transport Layer Security Protocol. And our Kubernetes API servers listens on the port 6443. Okay, which means, um, yeah, so those are the basic details of the Kube API server. Then, whenever any clients wants to communicate with our Kube API server, they needs to present their certificate. Similarly, Kube API server presents a TLS certificate during a communication. As we discussed here, that server needs to present its own certificate to the client, and client needs to present its certificate to the uh, server for making sure that these are the valid entities and these are not this communication is not happening with attacker, right? So where we can find this information, have we configured this? So far, we have been using our API server. We deployed multiple applications into our Kubernetes cluster. But where is this information when API server present the TLS certificate? Okay, so that information is present into a static pod manifest file of the Kube API server, and it is defined using this parameter TLS cert file and the TLS private file. Let's go to the manifest file. I have it here open, and this is a manifest file. It is the Kubernetes manifest, and this is a API server YAML config file. So as we already know, this is the static pod file for our starting our Kube API server, which have the multiple commands. And if you check these commands, you will find the information about the APIs, how API server is getting started. Okay. So Kube API server is running on this IP, and then it has multiple certificates and the keys file. For us, this is what we were discussing. So this is the TLS cert file and the private key of your Kubernetes API server. This is where our API server certificate and the key is present. Okay. Similarly, in the Kubernetes architecture, if you remember that Kube API server also talks with your etcd, right? So how this API server is going to present its certificate to the etcd client. So that information is present here. etcd CA file, etcd cert file, etcd client file, and your API server also communicates with the kubelet client and vice versa. So all those certificates and the key information is present into this file. Similarly, if you check any other manifest, then let's say if we check etcd YAML, then here also while starting etcd, we have the certificates of our etcd server cert file, and then we have the um, CA file, CA cert as well. Then we have these certs are for the peer cert, which means when we have multiple etcd components or the multiple etcd pods, then these certificates will be used. Okay, so it's not what we have done, but when we executed the kube init command, it did all those things for us. It created the certificate. It shared all those certificates with servers and the clients, and then it used those certificates while starting all these components. Okay, so I think that's what I wanted to show you on the server side. The next is how client authenticates to the API server. Okay. So there are multiple authentication strategies available into Kubernetes. For example, XY09 client certificates, your static token files, bootstrap tokens, service account tokens, OpenID, webhook, anonymous request, and yeah. So these are the different authentication strategies by which you can define the users and the its certificate and the credentials, how they can communicate with the server. For us, the important part is issuing a certificate for a user using X509 client certificates. Let's talk about that. Even though we know that there is no normal user resource available into our Kubernetes, like we can't create a user using kubectl create user command. There are different ways to create a user, this client key and the client certificate, and then represent that while communicating with your API server. So that's what I have written here. So even though normal user cannot be added via an API call, any user that presents a valid certificate signed by the cluster's certificate authority is considered authenticated. During the API server interaction, the client can also present its own TLS client certificate. This certificate is used for client authentication, ensuring that only authorized clients can access the API server. And this is what we call as a mutual TLS. Both parties in the communication can authenticate each other, enhancing the security of the cluster. Yeah, which means that we already have the certificate for our server, Cube API server. Now, if we can create the certificate, valid certificate for our client or any user using some way and sign those, get those certificates signed by our CA of the Kubernetes cluster, then maybe, not maybe, 100%, then our client can communicate with the Cube API server. Perfect. So as I discussed, there are 7 different ways. But for us, this is what we are going to see, and maybe we will also see service account token. Okay, great. So as we discussed, there are two main users in Kubernetes. One is normal users and one is service account. So to provide access to Kubernetes cluster for any normal user, we have different authentication strategies. And from that, we are going to check how to create a client certificates and keys to provide access to normal users. Okay. So here is how we can provide a authentication and authorization using X509 certificates. And for that, we are going to use one command, which is OpenSSL command. Okay, so let's get started with that. We are going to create private key and CSR for our my user. So this is command OpenSSL gen RSA hyphen out my user dot key and 204 8-bit. So it is going to create a private key for the user. So I'm inside my Kubernetes cluster, and once I run this command, it is going to create one private key. Using this private key, I can create a request CSR. Okay, so OpenSSL request a CSR using this key, and it is going to create one more file .csr for the name my user. Okay, so now we have private key and the CSR. This CSR we need to get signed using a Kubernetes seal. For that, we will create one file with this content, and the kind is going to be a certificate signing request. In this certificate signing request, we need to add our CSR. First, we need to decode this. First we need to encode the CSR and add that as a request to get that certificate signed. And who is going to sign? Is going to signed by the Kubernetes API server. And the yeah. Okay. So the CA certificate will be used to get these certificate, our client certificate signed. So let's create that file csr.yaml, and I'll just put this content as it is. This part, request part, we will replace by executing this command. Let me save this first. Okay, it's not allowing me to change this. So maybe I'll need to open this file as a sudo and change the contents. Okay. Yeah. So I'll execute this command locally cat myuser.csr and encode the CSR. It, it will give me base64 encoded content, which I need to add into my file as a request. So this is nothing but a base64 encoded certificate, which we need to get signed from our Kubernetes cluster C. Okay, so that is done. You can check the existing CSR using kubectl get CSR command. So this is the current stage. So let me delete the previously signed CSR and we will get the new certificate. Okay, so what we told is that we need a signed certificate and the expiry time is 1 day, I guess, 86,400 hours. And yeah, to authenticate to our Kubernetes cluster. Once that is done, using the user which has the approval to your CSR, that user, Kubernetes user, can only approve it. So for that, we are going to use the existing our Kubernetes admin user and get this CSR signed. So run the kubectl certificate approve user, approve and the CSR name. So what it's saying, the CSR not find, correct. So we need to run one more command to apply this kubectl apply csr.yaml. And now if you check the kubectl get CSR, it will show that the CSR is still in pending. This needs to be signed. Okay, and then only we will get a certificate. Okay. CSR is added. Now we need to approve that CSR. Once the CSR is approved, in the object CSR, it is going to save the certificate, signed certificate, which we can get it using kubectl get CSR command and extract the content of the status.certificate and save that into one certificate file. So I'm going to change the name of CSR here. My CSR name is my user, so I'll keep it my user and execute. If now we have three files, one is a private key, one is a CSR, and one is the certificate. Okay, so this is our certificate. We have signed certificate and we have a private key. So that's what we need for communication with a server, right? So we have both. Now we want to use those certificates and the private key to authenticate to the Kube API server. So how we can do that? Okay, we can update kubeconfig file where we actually puts the user client key and the client certificate, or directly by editing the kubeconfig file, or we can use one more command, kubectl config set credentials command, and it is going to update your kubeconfig file with the provided details. So what's it saying? Yeah, so this is done. Let me check. This is what we needed to do. So CSR has been approved. I have got the certificate as well. And now we can execute the command kubectl config set credentials and update our kubeconfig. So if you check the kubeconfig now, it will show you the new user with its client certificate data and client key data, right? So this is my new user, my user, and its private key and the certificate has been added into your kubeconfig file. So that is done. But as we know, context needs to be added into your kubeconfig file to add to bind your cluster and the user. Now we only have the user. You also need to bind that with particular cluster. So for that, we are going to run one more command, kubectl config set context, and I want to use my user and cluster Kubernetes. Okay. So for that reason, I'm going to add the context into my kubeconfig file. So let's verify that. If we go to context section, you will see here, there is new entry has been added for the context. The cluster name is Kubernetes and the username is my user. Perfect. Now to use this context, we can check the current all the context using kubectl config get context command, right? So there are two contexts. One is for the Kubernetes admin and one is for my newly created user. Now I want to use this my user to access my Kubernetes cluster. How I can do that? I can run the kubectl config and use context command, use context and the context name. Context name is my user. So this is the actual implementation of how we can create a client certificate, get signed using Kubernetes CA, and then how to update kubeconfig file, then how to switch to the different context and all. So now, if we do the kubectl git pods, we might get some error. Uh, okay, so git pods is fine. So if we do the git nodes command, so it is showing that this user, my user, cannot list resources nodes in the API group. And this is what we are going to see in the next video, how to provide this uh, my user permission. Sorry. So for this user, we want to provide the permission to list the node resources. Okay. So I already created one rule to and provided this user to list the pods and the deployments, but I don't have provided the permission to list the nodes. That is something which we are going to see in the next video. So for this authentication part, I wanted to explain in this video, and that has been our. I hope this is clear how the kubeconfig file plays the important role in accessing your multiple Kubernetes cluster and setting different users, clusters, then switching between the contexts, how to create the users, then how to create the certificates and certificate private keys for your user, how to provide the kubeconfig file for the particular user. Uh, now, this should be clear, but let me explain it again, the entire thing. So we created the user using OpenSSL. We actually created the client key and the certificate using OpenSSL. We got that CSR signed by the Kubernetes CA certificate, and that is what we need for accessing our Kubernetes cluster. That is one way to access your Kubernetes cluster. Okay, and we updated the kubeconfig file. Now, kubectl is going to check your kubeconfig file for those entries, and if those entries are valid, then only our Kubernetes cluster is going to authenticate to that particular user. Right? So, if we go back to our original question, how we can provide the different access to different users in our team. Now we saw that there are two different contexts here. One is a Kubernetes admin and one, this is what we created just now. Okay. So we can't, this is what I wanted to explain in the beginning, that we can't provide the Kubernetes admin level access to everyone. We need to restrict users to with particular access. We don't want to give the full access to everyone. So for that reason, we are going to create the users and their certificates, and then they can use these two commands, right? They can use this command, config set credentials, config set context, and config use context to update their kube config file with their relevant certificate and the key, which are signed by the CA certificate. Okay, so this is the entire process for on-prem Kubernetes cluster users management. There are different ways, but this is one of the ways. And this is I wanted to explain in this video. So, okay, perfect. And now uh, the next video is based on that, based on the kube config and the authentication. So make sure you watch both the videos and do the practical before the next video. So it will be very easier for you to understand how authorization works in Kubernetes and how we can add or remove permissions for the particular user. So yeah, this is fantastic. I think I'm also enjoying creating these videos, and hopefully you are also doing practical. As I said in the previous video, if you have any questions, you can reach out to me or share your questions in the comment section, or you can reach out to me on LinkedIn as well, and I'll be happy to help you with all your queries. I guess that's it for now. Uh,